Hey everybody on Zoom. We have an anonymous Zoom user. That should be good. We're working on a warm-up for arc length. As a reminder, for those of you that have not watched the video because you're slackers and may have forgotten arc length, S is 0 to T of the magnitude of dr. We're going to use a dummy variable. We're going to use U. So that's your reminder.
Lawrence getting the big guns out with those protein pots.
Well, arc length in general is that. I mean, I should say, since we have T is. Now let's do it in terms of T, and then we'll add in 3 to 4. Oh no, what are we gonna do here? This is so much work.
Don't worry,
There we
that's why
go.
you didn't see her do it.
3, -2, and 1. Oh my god, this is so challenging. Mr. Jones, these problems are too hard, Mr. Jones. But Mr. Jones, there's Mr. Blakely's voice. But Mr. Jones. I did that right?
Yeah, I hope so. I'm sure you were a math major. It's amazing, isn't that right, Mr. Jones?
Is what amazing?
Well, what you're doing, of course.
All of this is amazing. Blue and red are starting to show up better. I wonder if I use the orange and the green, they'll start working better too.
Oh no, I don't know. It's all about this either. All right. This is fine.
Did anyone else get that? So if we do from 4 to 3, we have 4 root 14 minus 3 root 14, which is root 14 units long.
What unit? Gotcha.
It's crazy.
This problem was fairly easy. The integration was easy. The derivatives were easy. It was all nice and straightforward. It was a warm-up. If we were to parameterize R of t, since that's what this is on, this lecture, let's do that. So we have S equals t root 14. Hopefully this gets darker. So t equals S over root 14. And we're just replacing that. R of t is now R of S. And we've got, I'm going to write it with the bracket notation. I hate writing I, J, and K. We've got 4 plus 3 S over root 14. Maybe I could just say 3S over 3 over root 14 S. There we go. That looks like I know what I'm doing.
You want to bring the board up a little bit? Looks like parts of it are. There you go.
And we got 2 minus 2 over root 14 S. And finally 5 plus, to keep the writing similar, 5 plus 1 over root 14 S. Where we're going with this, so when you start watching or reading 12.4, hopefully watching, I slave-takingly made these videos. I even made a nice little summary video that condenses everything without examples, so you can have all the equations and procedures in a nice little section. Where we're going with this is we use these in finding at any given point the tangent vector. That's not a tangent vector. Draw a tangent vector, Mr. Jones. A tangent vector.
Oh, 4 times.
A normal vector.
Any more?
No.
Are you sure?
And a binormal, which comes out of the paper, which is orthogonal to each of those. That's where we're going next. And this is relative. So as you're moving along, we have a different one over here. There's T over there. N goes that way here. B is still up out of the paper. And so we have this moving, constantly changing orthogonal framework. Instead of IJK, we are going to be using TNB. It's called the Frenet frame, named after Frenet or something like that. I don't know. But notice the stuff is changing. T is slightly different. N is definitely different. It's going the opposite direction. And like if we have it here, of course, T is pointing in a different direction there. Ooh, I wonder which way N is going right there because there's no curvature. I think it's that way. So it's constantly changing as we go from left to right, what our framework looks like. And that's why using something like this, where it's consistent from the point of view from the particle or car or whatever it is pretty handy. That's where 12.4 is going. We will use arc length as part of it. That's the 2 most common parameterizations are time and distance. Another common parameterization is we have this curve like this. Here's the x-axis, and here's my curve C. At any given point, the tangent angle, the angle it makes with x. So that's a parameterization that's used. Like how flat are we, basically? But it's not nearly as common as T or S. Time and arc length are where we're going for most of it. You will see when I'll let you guys finish writing this. find it where I want to have it here.
Mystery van and Russ Jones' background. The mystery van.
Wait, what mystery?
I heard my name, but I can't hear the words.
Oh. Is that the mystery van in the back here in your background?
No. That is artwork from one of the AI programs. That had dragon, samurai, and astronaut as the prompts. I'll leave it up for another minute, make sure everyone's got it down. Then I'll show you, before we start the next one, I want to show you some other formats of ArcLink.
Yeah, we got a question over there.
We gotta find a range for domain for S for parameterization, right?
Yeah. What should we do? Walk me through it. I know you know how to do this, Eric.
Plug in T into T domain.
That's
for
right.
S, so 3 less equal to S over 14, and less equal 4. Wow. Okay. Calculating too fast.
Because you're just
At least
putting-
for this problem. The problem was from T equals 3 to 4. In general, this thing could have gone forever.
That should be times.
Oh, I think that should be 3 root 14 and 4 root 14, not 4 over root 14 and 3 over root 14. Because you're just plugging in.
Oh, yeah. I fucked it up. My bad.
So that domain gonna be the mask, right? Without it, we gotta get point deducted. Is that right?
If you have the wrong answer, yeah. Don't
I mean-
do the wrong answer.
If we got a parameterization, but we just missing writing the domain.
It depends on what the problem says. Like generally, it's going to be if I have a domain on there, I'm going to ask you for the actual value, and you won't need to write the new domain, so long as you include it in your calculations.
Gotcha.
All right. If anyone else needs this up longer, shout out now, or otherwise I'm going to change to something else.
Yeah, next one.
Okay, so let me do a new share real quick. Oh, James will like this. He's a sicko. So in the ArcLink formula and other systems, 34, this is from our book, 12.3. Problem 34 shows you the ArcLink formula in cylindrical coordinates. And problem 36 shows you the ArcLink formula in spherical coordinates. And when you go far enough down the math rabbit hole, you will learn all of this. I think then we might actually do this when we get to partial. Now that I think about it, partial differential.
At the very least, I don't remember
Partial
doing
derivatives.
arc-length parameterization with cylindrical and spherical coordinates.
So that's cylindrical. That's, you don't need to know it, but just know that they exist. They're in the book. One of the problem, I think I get assigned 35 is something to do, so you get some practice doing it. But let's go on to our next problem. And where did I put that whiteboard? Let's try that bad boy. Oh, before we do it, I need to ask. So Physics 55 has a test on the same day as our test. I have decided to move our test to make it so that they're not like wanting to unload a barrel into their head. So we could either do it later that week, like on Tuesday or Wednesday, or we could do it the following Monday. If the perks of doing Tuesday or Wednesday is that you have less new material put in your head that's not on the test. We'll have to continue lecturing. So chapter 13, I'll start lecturing the short of that time, but it also means you don't have the weekend to study. If we do it the following Monday, you have longer to study for this test. However, there's going to be more content in your head that's like doesn't apply. And it also makes the next test feel that much sooner. So like by a quick show of hands, who wants it the following Monday? Brandon, count them for me because I can't see everybody.
Yeah. Got one.
I had a question, Niall.
What's your question,
Well,
Lawrence?
I'll give you for 3.
If we choose the one where we don't have a weekend study session, would you be willing to meet us at Danny's at like, say, like middle of the night? Like a midnight study session?
I'm not doing a midnight study session. No.
I mean, going Denny's at midnight doesn't even sound that all that far fetched.
It's all physics, move their time.
All right, let's try it again. Who wants to do it the following Monday?
Just cancel it.
1, 2, 3, 4. Pick one or not, or else I'm gonna.
So we could have it Tuesday, Wednesday, or the following Monday.
I'm thinking Wednesday is a better choice. I think Tuesday, if we do it Wednesday, we don't have to get chased out of class. Can someone check the schedule on the door real quick? On
I
the
got it.
outside of the door, it says the schedules, and if there's no class after 9 o'clock on Wednesday, I know there is after Tuesday. On Wednesday, there might not be any class after 9 o'clock. I can stick around longer.
Yeah, you're correct. There's no class right after this on Wednesday.
And I think it's the same with Monday also. We just had bad luck with Tuesday last time. So we could do it either Wednesday or the following Monday. So, Monday, the following Monday, who wants it? Put your hands up again, keep raising.
I'm seeing no hands.
So you guys want it Wednesday? Who wants Wednesday?
That sounds like a unanimous. Yeah.
All right, we'll do it Wednesday. Wednesday sounds good. I will make a note of that.
No, they're moving it like separate from that physics test. Yeah. Either way, you're not gonna have it on the same day as the physics test. Yeah. The vote was just like to ask him whether you wanted on like next, because you meant this, you didn't mean this Wednesday, right?
No. We have to finish the material first.
Yeah.
The week the test is scheduled, we'll just move it to that Wednesday.
Yeah.
And I will make an announcement of it. In fact, while you guys are working on the card, I'll type up an announcement.
But anyways, if I square this with one, like say, would I have to square all the other components?
Holy shit.
I thought you were doing.
What do you mean?
Like,
Yeah.
I'm saying like I can't square individual components. Like this obviously, I was thinking it would work, but it's not gonna work.
This through this, times this.
I do it different. I do that times through that plus that times through that.
Yeah, it's hard.
Yeah, I do it probably for the cheap the other way.
Oh, yeah. Okay, yeah.
Yeah, it's just for the first component.
Oh, okay.
Having the speech.
Oh, so you were asking.
I'm saying it, okay, so like,
If you were.
I thought real quick, no offense to my helper, data identity, but obviously that's never affect the square the whole thing, anyway. But
Well,
if I square this,
You
I
get,
have to square the root of that as well, right?
yeah, you have to square the.
Okay, so I have to square this.
Yeah.
You don't even know.
It's just, you're finding the.
I mean, it doesn't-
What even if so? Yes.
No, I'm.
Exactly.
Right, the formula down. Exactly, so. I write the formula down.
Oh, yeah, that's fine.
Yeah, I write cheat sheet in my head, so.
Actually, that's.
I don't need actually.
Yeah. Ready for the next one, James? You're that, Mr. Jones? James said he was
No.
ready for the next problem.
Ready for the next level? Is that what I heard?
I'm sure it's the same difference, right? We're only kidding, James. Or at least I am. I don't know about Mr. Jones.
I like hard mode. Let's do hard mode. I think the average test score was a little high if it's 77. I think I'm not doing a good job. I think I need to up my game. Make it more difficult. More power. All right. What do we need here? We need DRDT, right? Who fucked up DRDT? Let's see, our I component, I'll do our I component, J component separately. First we take, I know the book always does the derivative of the second one first. I think that's idiotic at best. I always do the derivative of the first one first. We have a product rule here, right? And then I take the derivative of the second. The derivative of the second is sign, negative sign. So we've got negative e to the t sine t. That's my I hat component. I hat component, and then J hat will be e to the t sine t plus e to the t cosine t.
I don't know, I'm just gonna.
So if I were to write that maybe as a vector, I could factor out the e to the t and put cosine t minus sine t, cosine t plus sine t. So now we want the magnitude of that, right? So e to the t squared is e to the 2t. And then I've got cosine of, I'm going to quit putting parentheses just because it's taking up too much space right now. Cosine t minus sine t squared plus cosine t plus sine t squared. And we have the square root because it's the magnitude. This could come out. This is just e to the t. And we need to do some distributing here and figure out what cancels here. I've got cosine squared t minus 2 sine t cosine t plus sine t squared, or sine squared t. That's from this one right here.
Yeah, you'll get to that.
The R squared, so yeah.
Yeah, you'll
I
get
know
to
that.
that.
I know stuff will cancel. Like, I'm just making sure not everyone that sees it right away. I don't want to just cancel out the cosine squared and sine squared right away. That'll fuck people up. That's someone that's not ready for it. So we'll do this one. Another cosine squared t. I've got a positive 2 sine t cosine t. I'm going to write this underneath here. And I've got another sine squared t. So for those of you that are up on your game, this adds up to 1. These two together make a 1. And these two cancel, right? So I have e to the t times the square root of 1 plus 1, e to the t root 2. That's my arc length. Arc or S. That's S, and we wanted it from 0 to pi over 2. So when t is 0, s is root 2. And when t is pi over 2, s is e to the pi over 2 root 2.
Can't see what you're doing.
Yeah, you want to move
I'm
the
off
board up.
screen. Sorry. No, Carlos, the following Wednesday. Carlos on Zoom. I sent an announcement. It'll be the 28th. We're not going to be ready for next Wednesday. We still need to do 12.4, 5, and 6. So the difference here, what we got? E to the pi over 2 root 2 minus root 2. That's the arc length. Now that part's a little bit easy. This figuring out the arc length. Let's take a look at how we put this shit into a parameterization. I'll leave that down there. We want this in terms of t. So we got e to the t equals s over root 2. And who remembers how to get rid of exponentials?
LN.
They said it. It was natural. They said natural log.
Yeah, we take the natural log of both sides. So natural log of both sides, I got t on the left, and I got natural log of s over root 2. We could leave it like that, or we could write natural log of s minus natural log of root 2. I think I like the condensed form better, but that's just a quick reminder on natural log laws. So if I were to put that in, I write this over here so I have a little more room on the board. We had, okay, so what does R of S look like? So e to the t is gonna look like e and the natural log cancel out. I just get s over root 2 for the e to the t part. And then I've got cosine of the natural log of s over root 2. And this is just repeated, except we have sine.
By the way, did you skip the integral? I know it doesn't mean anything since it's e to the t, but you didn't show that you did the integral at all. Doesn't look
No,
like.
you're right. I did skip the integral.
And you still get the same answer, you just.
Yeah,
skip the actual
you
integration
do.
part.
No, it is a different answer because there's the lower limit. It's like a -1.
Oh, you're right. Actually, he's right.
You're right.
0 to
I did. I skipped it and I fucked it up. None of that's right. All the way back. Woohoo!
That's why you gotta pay attention to your
Uh-huh.
0.
Thank God for tablets.
This is why you tell me when I'm doing shit wrong. Tell me right away. So
You're right.
s equals the integral from 0 to t of e to the u root 2 du. So this becomes e to the t
Oh,
root 2. I'm sorry, minus e to the 0 root 2. The arc length is. I skipped this up here, going too fast. E to the u root 2 evaluated from 0 to t. So e to the t root 2 minus root 2. That's arc length. So let's plug that in. You know what? And again, to save space, I will write this here.
Don't you also need a cell for T?
Yeah, I do need a sulfur T. I haven't done it yet.
Oh.
So we add the root 2 over. We divide by the root 2. Plus 1. And so T is the natural log of S over root 2 plus 1. So that's what goes into our fantastic R of T. R of S. We've got an I component that is this. We've got plugging E or this into the E to the T. We just get S over root 2 plus 1. And then we have the cosine of the natural log of S over root 2 plus 1. That's my I component. My J component looks identical other than it is sine. I don't know, Brendan, do you think this is a test we should have on the problem?
Yeah.
You mean a
Oh,
problem?
wow,
you
that
should have
just
on
made
that?
no sense. Should this be a problem we have on the test, especially if I have them do calculate T, N, and B with it?
Just give them just make sure you give them the whole page to actually do it, so they actually have a room to put it on. Or else
Oh,
they'll
they
go on
need more than a page. It took a page just to, well, I'm writing kind of big because I'm using these big old fat markers. But
Yeah, you got to make sure if you're going to put it on the test, make sure they at least have enough room to put it on.
I wouldn't
Otherwise,
do
you're
this.
not.
This
How are
problem
you-
is way too complicated.
Yeah, I was gonna say because otherwise, how else are you gonna put all look at all the trivial mistakes they make?
Right? So it's complicated. And it error prone. If you
Oh,
get
yeah.
going too fast, you start skipping shit like Professor Jones did. Professor Jones actually skipped doing the entire fucking integral. He spent all that time. Now I tell students, don't do this. Make sure you write the formula out the whole time. And then what do? I show dr dt rather than putting it in an equation. Or putting it into the integral right away. If I had it in the integral right away, I wouldn't have made that mistake. But I did. I fucked it up.
Skip steps if you want, if you can, just know the consequences.
Right. If I were doing the test, I would probably have shortened this section. I would have probably, well, I don't know. You kind of want to show where you get your shit from.
Yeah.
But I probably would have, to save space, I would have said sine 2t right here. Just because I'm a slacker like that. Does this look like something you want to work with, though?
Not really.
Not really, right? Not only do I have a product rule,
Math row make mistakes.
but then when I do the derivative, like if I'm working on the derivative of this side, I then have a double layered chain rule. So this is an ugly problem if you're going to try to do, you'll see when we're doing tangent, normal, and binormal in 12.4, we're taking derivatives. Do you want to take the derivative of even one of these? No.
Time to open up Wolfram.
Wolfram doesn't work on a test because you don't have Wolfram. I'm not a slacker like Quinn. You got to do the actual math here. Quinn could get away with it. He's not teaching the mathematics. I am. I have to make sure you know how to do the math.
At this rate, you're gonna have a whole lineup of teachers outside your house ready to fight.
And you know Mr. Redden's gonna be at the front.
No, Mr. Red's not. And I've been to Dr. O's house. He won't do nothing to me.
He won't.
Now, I don't know about Quinn and his wife. They might, they look like they're ready to, they might be the local massacreists. He looks too nice, right? He looks too nice, too friendly. I don't know if I trust that. I don't know. I haven't. How is he as a teacher? He's always quiet when I see him out in other things like at SETA or Mesa. I've seen him or FNL.
I think he's a good teacher. He's like, he's like ready to like basically drop everything and help you if you have a question. He's
Cool.
Very, yeah,
I'd say he's pretty, and I have him for intro to engineering.
his wife, however.
Well, I've never met his wife, so.
So you guys can see the algebra on this can get complicated. Most of this shit was algebra. We only did an integral or derivative up here, and we did an integral right here, but the rest was a lot of algebra. So don't rush it. Algebra is an easy spot, especially when you're comfortable with something. It's easy to go too fast and fuck it up. So go carefully. I don't know that we have time to start another problem and work it all the way through. So if you guys don't want to ask questions or you guys want to work on homework together or stuff like that, let me know what you guys want to do.
I got a question.
Yes, Eric.
Yeah, you might want to come up here. It's gonna get loud.
The interval and the derivative.
Camera check that.
Oh.
I mean, I feel like,
Oh, sorry.
if he asks, if he asks a question, I feel like it's good.
I'm not going to be able to see it without stopping sharing.
I mean, like, I don't know. I feel like it's good for everyone to know what his question is.
Yeah, so just verbally ask it. Maybe I can do it on the board.
Okay.
Oh, yeah.
Okay, so I'm gonna tell you if you can.
Yeah.
Oh, so it's
Okay,
S
so
plus-
right now I got this.
I didn't turn it to equal. that.
And
I
this
was-
is the corner for S, right? So if I plug. So I get. That always works. Sometimes doesn't work.
Are you saying, so you're asking if you plug in those values here, yeah. Repeat that. Yeah.
Into here.
Yeah.
Works well. It looks like a vector.
Okay, so the question was about the when you're solving for the interval for your limits of integration. He was asking if you could just plug in the two t values into S to find those boundary values, or if you have to solve for t first and then implement it into the.
You do not,
limit.
if you're just finding the arc length and doing it from there, you do not need to do the step I did. You do not need to do for T first. I was doing that because you guys are going to be doing it for T first from here on. Most of the only time we're really just doing arc length on this particular region is when we're only looking at a particular region. Knowing how to do it in general is a better way to teach it. But yes, in terms of doing the actual problem, I would have put 0 to pi over 2 in right here.
I don't think he understands that question.
No, what he was asking was, you know how when you're that interval you had like from 3 to 4 from the last problem.
Or 0
So-
to pi over 2 here.
Yeah. So you had to. The idea was you have it's 0 from 0 is less than or equal to t, which is less than or equal to pi over 2. He was asking, do you have to solve for t from the parameterization you get, so that s equals e to the t root 2 minus root 2? Do you have to solve for t to get that and then put it into the interval to find those limits of integration of s, or can you just implement the two limits from 0 and pi over 2 into t from that arc length you have already?
You couldn't possibly do this because this is the answer. So you couldn't possibly put, you don't want to, if you try to put them in, you should put them in as is. Work with T, because we don't have S in here. And we're solving for S. So you can't that would be a circular thing. We don't want S on the left side and have the integral of S in here. We can't change this to an S until we know what S is.
I'm really bad at explaining this because you're missing the question.
You're asking, what do you know? What he asked is, from what I heard, is can we, right now this says 0 is less than or equal to T less than or equal to pi over 2. He wants to know if we can do this in terms of S is A is less than B and do this integral from A to B. Is that what I'm hearing? Is that the
No, not at all. He was asking if he, in terms of getting from A to S to B, he was asking if he could just implement, if he could just use how do I explain it?
All right.
He wasn't.
Professor Jones, can you take a look at the Discord? I sent a picture on Calc3.
It might be easier to look at it.
So I got my double line under S equals square root 2 e to T minus 1. So can I plug in the T value 0 and pi over 2 to find the S value, S range? Or domain. He's still confusing. I need to find a picture to help. And my picture is like that. Okay. Sorry, I can't believe my phone. You can.
I'm over here looking at sideways.
Of course.
I need to.
Can you just share your screen?
No, I'm just.
Can you just share your
So
screen?
let me rewrite what I see, what he has.
Actually, we did. Once we found this first, push everything.
This is hard to look at.
I'm taking another picture for him.
It's like, yeah, please. And since the time is.
I don't know why.
Okay, so what I'm seeing Eric doing is trying to get the limits, find the boundaries here. He's trying to get to this and see what's on the outside. I don't think doing it the format he's doing, where he's solving this algebraically, is the best approach. What I would do is I would go and start with, we've got T equals natural log of S over root 2 plus 1. And I would just plug in, oh, I guess you kind of have to. Shit. I would do this here without having all the, I can stop pulling this sideways. I would solve it here and go, okay, we've got e to the T.
Can you see it?
Equals S over root 2 plus 1. E to the T minus 1. Root 2 equals S. And then I would plug in my 0 and pi over 2 here. I wouldn't try to do it in this thing right here, because then you've got, it gets convoluted. I would solve here and then plug them in. So e to the 0 is 1. 1 minus 1 is 0. So when t equals 0, s equals 0. And when I got t equals pi over 2, am I still on screen? Let me make sure. Yeah, okay. So I wasn't up there. I think that's the hard way to do it. Solving it for t without the boundaries. I do it here, plug in t and figure it out here.
Wow. Wow.
It's the same thing. But you have the less, you don't have to worry about having the less than or equal to the whole way in there.
Okay, go ahead.
It's a little easier to figure out what you're doing.
All right.
Does that answer your question?
Yes.
Okay, good.
Either way.
Yeah, he's asking if you could do it that way.
You could solve it right there. You could solve it with that. You just have to do this all simultaneous. What we did here, you're doing
Yeah.
simultaneously on the line, and I think you're more inclined to make a mistake if you do so.
Yeah.
Like to prove this, and you gotta wire that.
Okay.
or something, and you gotta ask people. You know, it's why it's like this. You're gonna go out and exit when there's.
Yeah.
Yes.
You got the works. Always working, man. Well, you guys are having fun.
Yeah, so that's your, that's your.
For those of you leaving, I'll see you guys tomorrow.
Like between 2 points. So that's finding from 2 parts of it. This is the arc length.
How's your week going, Professor Jones?
It's going all right. My cousin from Florida is driving through to Sacramento today, so I'm gonna have lunch with him.
Oh, nice. That'll be fun.
Yeah, I haven't seen he was like 5 when I was a teenager, and I haven't really seen him since he was like 5, except on Facebook and stuff. So it's gonna be fun seeing him all grown up.
Yeah, for sure. Get to see the adult version of him.
Right.
Sounds fun. Well, have a good day and have a good time with your, you said it was your cousin?
Yeah, it's my cousin. Thank you.
Cool. Yeah,
You guys have a good day too.
sounds good. Thank you, Professor Jones.
Did you have a question for him?
Nothing, just that, study at Starbucks this Saturday.
Yep, I'll be doing Saturday and Sunday.
I don't know how can tell you to visualize that.
All right,
Don't
then,
get
Professor
used
Jones.
to it, 'cause, Miss Bren won't do this.
Have a good rest of your day.
You too.
Like, my understanding is that the length, you know how it's instead of in terms of time, you have a different length, right? Yeah. So as it goes along this line,